topic is the main type of methodologies in the assessment of desirability in economic and environmental or social aspects of constructing a highway proposal. So the first one is the economic appraisal of highway schemes. In the development of a highway project, the developer will require economic assessments of the route options under consideration. And these are the methods used in the economic evaluation. The application of the economic analysis allows the decision makers to make better choices or options regarding the alternative uses of the scarce funds. And in the case of the infrastructure alternatives, those choices are made under the conditions of limitation. And the most common limiting factor is the availability of the financial capital. And also, due to the scarcity of resources, decision makers must direct their expenditure to those projects that offer the most efficient outcomes. And itong cost-benefit analysis or CBA can be used to help make these decisions. So what is cost-benefit analysis? It is the method usually adopted for the economic evaluation of highway schemes, utilizes the net present value technique where the cost and benefits of the schemes are discounted over time so that they represent present-day values. Using this method, any proposal having a positive net present value is economically sustainable in absolute terms. In this technique, there are main types involved, and these are the listing of the main project options, the identification and discounting to their present values of all relevant costs and benefits required to assess them, and the use of economic indicators to enable a decision to be reached regarding the proposal's relative or absolute desirability in economic terms. So let us proceed to the identification of the main project options. This is a fundamental step in cost-benefit analysis process where the decision makers compile a list of all relevant feasible options that they wish to be assessed. It is usual to include a do-nothing option within the analysis in order to gauge those evaluated against the baseline scenario where no work is carried out. So what do we mean when we say to do nothing? By this, I mean simply accepting things as they are. Like all options, the risks and benefits of doing nothing have to be considered. At ito yung mga options na hindi na kailangang baguhin pa or wala na kailangang baguhin pa. While the do minimum option offers a more realistic course of action where no new highway is constructed but a set of traffic management, improvements are made to the existing route in order to improve the overall traffic performance. The do minimum option provides the least cost solution for achieving the project goals. There are many procedures for both identifying and defining project options, and these include the drawing of the personal experience of the decision maker himself, as well as other experts in the highway engineering field, making comparisons between the current decision problem and ones previously solved in successful manner, and also examining all relevant literature. And for us to have new options, we need to brainstorm. Brainstorming consists of two main phases. Within the first, a group of people put forward in a relaxed environment as many ideas as possible relevant to the problem being considered. So the main role for this phase is that members of that group should avoid being critical of their own ideas or those of others, no matter how far-fetched. The second phase requires the planning engineer to return to normal judgmental mode to select the best options from the total list, analyzing for each technological, environmental, and economic practicality. In identification of all relevant costs and benefits, there are three primary user benefits, and these are the reductions in vehicle operating costs, savings in time, and reduction in the frequency of incidents. And there are also secondary groupings of benefits, those accruing to non-users, and this include positive or negative changes in the environment felt by those people situated either near the new route or the existing route from which the new one will divert traffic, and also the loss or improvement of recreational facilities used by the local inhabitants, or the improvement or deterioration in access to these facilities. The economic life, residual value, and discount rate are the parameters of a project. Economic life, it is related in principle to the expected lifetime of the project under analysis. The residual value is the estimated remaining value of the asset at the end of the evaluation period, while the discount rate translates all costs and benefits to time equivalent values, and it is the interest rate at which future payments are reduced to a common time. Any of this technique can be used to assess the basic economic viability. The net present value will estimate the economic worth of the project in terms of the present worth of the total benefits. The internal rate of return will give for each options under considerations the rate at which the net present value for it equals 0, with benefit or cost ratio based on the ratio of the present value of the benefits to the present value of the costs. Advantages and disadvantages of cost-benefit analysis. For advantages, the use of the common unit of measurement, money, facilities, comparisons between alternative highway proposals, and hence aids the decision-making process. Another one, it offers a broader perspective than a narrow financial or investment appraisal concentrating only on the effects of the project on the project developers, be that the government or a group of investors funding a toll scheme. And for the disadvantages, the primary basis for constructing a highway project may be a societal or environmental rather an economic one. The method is more suitable for comparing highway proposals designed to meet a given transport objective rather than evaluate, and the environmental consequences of the project in question tend to be neglected or at best downgraded within the main economic analysis. Payback analysis is an extremely simple procedure that is particularly useful in evaluating proposals such as privately funded highway projects where tolls will be imposed on users of the facility in order to recover construction costs. The method delivers an estimate of the length of time taken for the project to recoup its construction costs. To compute for the payback period, here is the formula, where payback period is denoted as N sub P, C sub 0 is the initial construction cost of the highway project, and NAS is the net annual savings. So that is the end of my discussion. I am Melanie Jimenez, and for the further subtopics and the topic number 2, it will be discussed by my group mates. So stay tuned and thank you for watching.
Hi guys, I am Jibin Splana, and this is the continuation of scheme appraisal for highway projects, and this talks about the environmental appraisal of highway scheme. So, the National Environmental Policy Act of 1969 requires the preparation of an environmental impact statement, or EIS, for any environmental significant project undertaken by the federal government. So, in connection with this, the NEPA prescribes a format for the EIS requiring the developer to assess the following. Number 1 is the probable environmental impact of the proposal. Number 2 is any unavoidable environmental impacts, the alternative options to the proposal, Next is the short-run and long-run effects of the proposal and any relationship between the two. And the last one is any irreversible commitment of resources necessitated by the proposal. The 12 environmental impacts forming the assessment framework are the following: air quality, cultural heritage, construction disturbance, the impact on ecology or nature conservation, landscape effects, land use, traffic noise and vibration, the impact on pedestrian, cyclist, and community effects, vehicle travelers, water quality and drainage, geology and soils, and policy and plans. Some of the above impacts can be estimated in quantitative terms, other only qualitative. DMRB advises that an EIT be constructed for all relevant appraisal groups. So, ano nga ba yung mga appraisal groups na yun? Number 1 ay yung local people and their communities. Another one is the travelers, which consist of drivers and pedestrians. And the last one ay yung cultural and national environment. Dito naman ay makikita natin yung listing of impacts relevant to each of these appraisal groups. As you can see, on the left part ay yung appraisal grouping and on the right part ay yung impact niya. Furthermore, this table is a sample EIT for local people and their communities. So, dito nagmamanifest yung sinasabi na yung pag-analyze dun sa mga impact ay pwedeng quantitative and pwedeng qualitative. As you can see, in noise ay quantitative yung analysis niya, and on the other hand ay sa visual impact, severance ay meron siyang qualitative analysis. Moving on, another scheme appraisal for highway project is the new approach to appraisal or the NATA. So yung appraisal summary table or the AST ay design para sa presentation to those decision makers which are in charge with determining whether to approve or disapprove a specific project proposal. It does constitute a key input into the process of scheme approval and prioritization. The AST summarizes the assessment of the scheme in question against the following 5 objectives and their constituent impacts seen by the government as being central to transport policy. These are the following: environmental impact, safety, economy, accessibility, and integration. But kung papansinin natin, yung environmental impact ay katulad lang nung environmental appraisal which was previously discussed. So this talks about noise, air quality or air impacts, landscape, biodiversity, and heritage and water. That's why we will focus on the last 4. So safety. This criterion measures the extent to which the proposal improves the safety for travelers. So ano ba yung magiging impact ng specific project proposal sa safety? This requires accidents to be broken down into those causing death, those causing serious injury, and those resulting in only slight injury. The next one is economy, the degree to which the proposal contributes both to economic efficiency and to sustainable economic growth. So, kung ano yung magiging impact ng specific project proposal dun sa economy ng isang state, ng isang bansa, or specific city. There are 4 indicators used in the economy. Number 1 is journey times and vehicle operating costs, yung haba o tagal ng biyahe at yung operating cost na ginagamit dun sa specific vehicle. Number 2 is cost, which talks about the cost of construction. Yung reliability naman ay assesses the impact of proposal on the objective of improving the journey time, reliability for road users, and on the other hand, yung regeneration ay nag-evaluate whether ang isang proposal is consistent with government regeneration objectives. The next is the accessibility. So yung accessibility ay nag-relate to the proposal's impact on the journeys made within the locality by modes of transport other than the private car. Example niyan ay yung mga pedestrian, cyclist, equestrians, yung access sa public transport and community severance. So yung community severance ay mode of transportation in which they are not motorized like what is shown in the picture. Next is the integration. This criterion assesses in broad terms the compatibility of proposal with land use and transportation plans and policies at local, regional, and national level. There are 3 contextual scales used in integration. These are beneficial if more policies are facilitated than hindered by the construction of the proposal, adverse if more policies are hindered than facilitated by the construction of the proposal, and neutral if the net effect on policies is zero. Now we are moving on the next main topic of this vlog, which talks about the basic elements of highway traffic analysis. So, ang analysis ng parameters on highway traffic will directly influence the scale and layout of the proposed highway together with the type and quantity of materials used in its construction. So, napakahalaga nitong basic elements of highway traffic analysis. The section of this topic are speed, flow, and density of stream of traffic, determining the capacity of a highway, the level of service approach, and the last one is the estimation of AADT for a rural road in its year of opening.
Good day everyone. This is the continuation of following subtopics under basic elements of highway traffic analysis. So, what is level of service? For transportation facilities, our interest is not just in determining the maximum number of vehicles, passengers, or pedestrians that a facility can accommodate, but of equal interest quantifying the quality or the known as level of service. So, for example, in the case of highway roads, especially in rural area, when there are only few vehicles on the road, drivers are free to choose whatever speed they like, consistent with the conditions of their vehicle and the geometry of the road. As the flow level or volume increases, vehicles get closer to each other, so congestion develops and the speed at which drivers can travel are reduced. And in some point of extreme cases, gridlock can occur and vehicle speed approach zero. The Highway Capacity Manual in the United States lists 6 levels of service ranging from A to F, or from best to worst conditions. So, from Service A to Service B, comfort and convenience levels for road users are very high as vehicles have almost complete freedom to maneuver. And pagdating sa Service C, minor accidents are accommodated, so dito restricted na at kailangan ng pag-iingat when changing lane. So, when it comes at level of Service D, flows are maximized with speed at approximately 50% of its maximum value. At pagdating sa Service E, unstable na dito ang traffic flow. And lastly, to Service F, flow levels tends towards zero. This graph shows the 6 levels of service ranging from best to worst. So, hourly volume, it is the highest hourly volume within a 24-hour period. And to get the peak hour factor, hourly volume divided by 15-minute flow multiplied by 4, and the other service flow is equals to 15-minute flow multiplied by 4. And to get the maximum service flow rates for multi-lane highways, it is equals to C sub j multiplied by open and close parenthesis B over C sub I multiplied by n, where n is the number of lanes in each direction, and C sub j is the capacity of a standard highway lane for a given design speed j. From Table 1, it shows the values of C sub j for different design speeds, and from Table 2, ratios of flow to capacity for different levels of service and design speeds. Example problem number 1. So dito given ang ating hourly volume at ang ating peak hour factor at pinapadetermine ang level of service being provided by the highway. So dito direct substitution sa formula ng service flow na equal sa 2,312.5 vehicles per hour at pagkatapos kinuha naman ang maximum service flow na equal sa 0.58. These are the formulas for non-ideal conditions wherein F sub HB is the resulting reduction in capacity and F sub W adjustment factor and F sub E is the correction factor. Heavy vehicles such as trucks, buses, and recreational vehicles have a negative effect on the capacity of a highway due to their physical size together with their relatively slow acceleration and braking. So these following tables show the different values for non-ideal conditions. Example problem number 2. Determine the level of service of this section of highway. These are the following ideal conditions for maximum service flow rates for two-lane highways. Formulas for ideal condition and for non-ideal condition. Example problem number 3. Calculate the service flow of the highway when running at full capacity. Sizing a road using the highway capacity manual approach. When sizing a new roadway, a desired level of service is chosen by the designer. This value is then used in conjunction with the designed traffic volume in order to select an appropriate cross-section for the highway. Example problem number 4. Calculate the required physical extent of the highway and the number of lanes required in each direction. Estimation of average annual daily traffic volume or AADT.